Yeah, so hi everyone. Ashwin, Manjula, Shikha. Only three people. Day by day, attendance is decreasing. Last week, I guess you guys were busy with holidays.
Yes, sir. Yeah.
Hmm. Only one person joined. Saurabh, today he's not here. Literally taught him machine learning from scratch that day.
Yes, sir. I saw the recording.
Okay, you got the gist of it.
Yes, sir. Like I have a background in ML,
Great,
so
great.
it's fine. Yeah.
Okay, so as like last time I emailed, so I told you na I will show you how the social network analysis stuff, Manjula, only for you, I wanted to discuss how to use a real world data set and how to perform this stuff. Whatever is being taught in the course on that real world data set to analyze that data. So either we can discuss that. Yeah, Ashwin, please go ahead.
Yes, sorry for interrupting. Actually, there was this question in the week three assignment, which was the last question. I don't know in the order whether it is the same for everyone, but the last question it's about what Stochard's model. And so the question asks about the minimum and maximum values for CCWS.
Yes.
So I had marked three by four because it is not a range. I thought it's like three. It has to be three by four precisely. So I don't understand how the answer should be 0 to 3 by 4.
Just a second. Based on the following formula for clustering coefficient, determine the minimum and maximum values of CCWS given that the node is connected to k by 2 forward and k by 2 backward nodes. Just a second. I have some solution written here. Just a second. Actually, I didn't make this assignment. This was made by my colleague. So I need just let me check. Yeah, so she has a solution. Okay. Either I can share the solution directly or I can discuss it. Let me discuss it. Let me connect my iPad. Also, I had to discuss one doubt of Shikha, and one person emailed me. He hasn't joined the session, and I don't think so. He's in group also. So reciprocity related doubt he had, week two doubt. Do you guys have that doubt, or that there was a reciprocity formula which told the value of reciprocity for that graph was 1 by 3? So, but he told it's 1 by 2. He performed some computation, but there were some mistakes, not per se mistakes, confusion regarding notation of that, because sir has told something, but that is correct, but he hasn't clarified it clearly. And I'm not saying it's not clarified in the sense, because if you solve the question, you will get it. It's clarified, but if the person doesn't solve it, it's difficult to get it. But I'll discuss it anyways. I have the solution with me. Mm. So let me. I cannot open it. Okay. Let me just write the question on the iPad itself. So formula for CCWS is 3 k minus 2 by 4 k minus 1. Manjula, did you solve this question?
I don't know, sir.
You didn't get the answer correct. If you guys don't get the answer correct, just ask me. I'm sitting every weekend here. I'm just discussing stuff from here and there. You guys don't ask these questions. Okay, anyways.
Yeah, sure.
Uh, so
So little bit maximize that window now. Ah, yeah. Yeah, now.
just let me wait a second. Let me rotate it.
Yeah, now it's.
Okay. So given that each node is connected to k by 2 forward and k by 2 backward, that is basically the whole point of what Spokats. It's like rings, this type of structure, chain linear ring type of thing. Okay.
So, can you show me the questions? Which question?
Question I can show you, but then I have to remove my iPad from sharing. Let me. Uh, I can copy paste here. Okay.
Yeah, yeah, yeah.
This one and this is the formula. The answer was minimum value was 0 and maximum was 3 by 4. So yeah, clustering coefficient CCWS obviously depends on the value of k. What is k here? Guys, what is k here? K. Ashwin?
So I don't recall well, but then it's like it is connected to K
That is the
nodes in
degree.
all.
Degree of each node.
Right, right. Yes.
Yeah, it is connected. That's why it is degree of each node. Okay. So depends. Obviously, CCWS depends on the value of k. So we are basically finding the limits. Okay. So the minimum value of k. Minimum value of k is 2. Why is it 2? Because a node can be connected to one forward node and one backward node. Correct?
Yes, sir.
So if you put k is equal to 2 in this thing, so this thing gets cancelled to 0 and CCWS is equals to 0. That's how you get the minimum value. Got it?
Got it, sir. And then so the maximum would be
K tends to infinity.
okay.
K tends to infinity. So this thing k minus 2 by k minus 1 tends to be 1. So answer is 3 by 4. CCWS is equals to 3 by 4. Okay?
Yes, I got it. Thank you.
Any other question? Any other question in
I
week
know.
3, week 4, anything? Okay, so yeah, Shikha, your doubt. I have it here. I wrote it down somewhere. Yeah, got it. So, okay, just be with me and answer me whatever I'm asking because that thing is going to be very easy. And you also,
Okay. Yeah.
let me open your mail. So now what I have started doing is I'm just starting this practice. So if you have any doubt of any assignment or something, just email on that group first. Okay, Ashwin, you as well, so that I can prepare around that doubt and everything. If you want to ask some examples related to it, so in that way you will have a proper and better articulated solution instead of just me guessing around the question and like that. So last time also I told I will email it today as well. So yeah, okay. So you are asking what is the time complexity of finding k click, k click.
Sir, there is a like typo in that mail. I wanted to type order of n power k,
I got
but
it. I got it.
yeah. Okay.
I I got it. That's what I'm saying. You want to ask how the answer is coming.
Right. Yeah, yeah, yeah.
Yeah.
That is
So
the
you told n into k, and I will tell you why is it not n into k, because I know what mistake you did there, and it's a very
yes.
very common
Yeah.
mistake. Okay.
Okay.
So n click k click, you have to find, and with n nodes. So just assume you have a graph with how many nodes are there? One, 2, 3, 4, 5, 6, 7, 8. There is a graph with 8 nodes. You have to find a 4 click. So what you can do is simply first find one node out of that graph. Okay. First take out one node out of that graph and check if it's a part of 4 click or not. Okay.
Okay.
Then check another node if it's a part of 4 click. Okay. Then check another node. I'll tell you the mathematical solution as well. I'm just telling intuitive solution how you can come up with this type of things. Okay.
Okay. Okay.
So you check if it's a part of some 4 click or not. Okay. If it's a part of 4 click, very good. Then check another node. Okay.
So how do we check a node is part of a click, like a K click?
The k path type of thing is there, na? The path between any two nodes should be at max k. Something shortest
Okay.
path
Okay.
between the nodes should be at max k.
Okay.
That is the click basically. I will show you the video as well. Anyways, you can watch the video on YouTube. We discussed this last week, how the k click thing is working. Okay. So yeah, then you go to another node, then you go to another node, third node, and then you go to the fourth node. So once you go to four nodes, your 4 click is done, correct?
Right. Yeah.
And the property of click is the nodes outside the click also contribute to the path of click, correct?
Yes. Yes. Yeah. Yeah.
So it means when we checked for this node, we also have had to go through all other nodes. When we checked for
All
this
other
node,
nodes. Right.
we had to go for all other nodes. Okay, so we checked. What is this? We check n nodes k number of times. Getting it?
Okay. 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 Yeah. Each node.
Yeah.
Yeah.
So
Okay.
first time we check n
Right.
nodes, then we check n nodes, then we check n nodes. We do it k
Right.
number of
Right.
times.
K times.
So
Right.
power
Right. Right.
becomes n to the power k.
Okay. Okay.
Okay.
Mm-hmm.
This is very basic intuitive solution. Now, why your answer was n into k? Okay. So let me discuss that as well. What you did was you didn't you didn't count. You you basically tried to permute k nodes out of that n nodes one by one, something like that. So say you take out 4 nodes out of these n nodes, you take out k nodes, and then you check whether it's a part of click or not. So you that is somewhat that is like that's intuitively you think that is correct, but it's not correct as okay. But
Okay.
anyways, mathematically, let me show you how is it, because the math explanation is very beautiful. It requires some properties as well. Okay. So the brute force approach. Let me discuss the brute force approach. The brute force approach is to find k click out of n nodes. We do nc2 nck sorry nck, correct?
Right. Yeah.
Okay, which is anyways you can simply write as n factorial by k factorial
Exactly.
n minus
And
k factorial, like that. Okay. So whenever we want to check the complexity, we basically move this thing to infinity. Okay,
Okay.
we move this.
N tends to
Yeah.
infinity.
Okay, so either you can check for all the pairs. Okay, I have written it, just a second. Yeah, the process so there's a property basically. Okay, this property is in PNC. If you check PNC, you will find, so for n tends to infinity, and I will show you intuitively again. For n tends to infinity, nck tends to o to the sorry n to the power k,
Okay. Okay.
where k is fixed. K is fixed. Okay. And this is very intuitive because you have to find k samples out of n samples.
Right.
And when n tends to infinity, so this means you cannot search first for n, then again for n minus 1, then again for n minus 2. Okay, because the infinity number is very large, so it does not become something like n factorial. It becomes n into n minus 1 into n minus 2. This thing becomes n into n into n into n. Okay, so if you
Exponential.
simply put infinity type of thing here, it becomes n to the power k if you solve this
Understood. Because
expression.
n is very large.
Yes. So this is the other doubt. Okay. And let me just discuss the third one. I have it
So
written down.
in week 5, fourth question assignment.
Just a second. Fourth
So if
question.
A, B, C, F, E is a K, Q, Q, what is the value of K?
Just a second. Just a second. Week 5 assignment question number.
4, sir.
Okay.
So and also I need a clarification of K, Q, and K clan and K club.
Arey, I discussed it
2P.
na. I discussed it na in last week's video.
So last week I didn't attend that. I will check this.
Just watch that video. It's explained very clearly there. Okay.
Okay. Yeah.
So in fact, this question also I discussed there. What is the
This
value
one,
of
4.
k? K is equal to 2. That answer I discussed. So if you take A, B, C, F, E, okay,
Mm.
then
Yes,
D
yes.
node is not in the part of click, but its path is getting used. So path between C and E is of length 2. Path between B and E is of length 2. Any nodes you can get by moving with length 2. So that the value of k is 2. So this set of node 5 is basically a 2 click. Okay, this is very simple in that if you just watch that video, I've discussed it there. Okay.
Check.
Okay, so I will, let me just open up.
Charge is down, sir.
Sorry.
Charge. Your iPad charge is down.
Oh no, I put it on charge, I removed it, I don't know why. Okay, just I need to first open that video. It was in week 2 lecture 6 or something. Okay, I can show you email here as well. So see that email first. Um, hmm, okay. So you are looking at this. Hello, everyone.
Yes, sir.
Is this thing clear, Shikha?
Yeah, clear.
Anyways,
Yes.
I will discuss it anyways because that person might watch the video later on. I will discuss it. Okay. So first, I'll discuss what is reciprocity. Mhm. Which week was it? Lecture 11. Okay. Chapter 2, lecture 6. Okay. So reciprocity basically counts number of loops of length 2. Okay, so there's one node, there's one other node. This is basically a loop of length 2, path length 2. Okay, so how does it gets computed? How is the formula moving? Okay, so formula is total number of reciprocal pairs by total number of pairs. So there are 3-4 formula given in this discussion, so that's where the confusion arrives. I will show each and every one of it and how you can do it. So say there's 1, 3 and 2. Okay, so the value of C here is there's only one loop. Okay, and number of pairs are this 1, 3 is one pair, this 1, 2 is another pair, and 2, 3 is another pair. So the answer is 1 by 3. But okay, let me just discuss the other formula as well, and then I'll show you why that guy got confused. Okay, so just imagine you are given now an adjacency matrix. The adjacency matrix is Aij. So now R becomes 2 by E. This is reciprocity basically. R is equal to C, whatever it is, same equation. So we do summation I is less than j. We perform Aij, Aji. Okay, so this basically tells if the value of Aij is 1 and Aji is 1 when I is less than j. So why I less than j? So if I want to check 1 comma 3, and then this will check 1 comma 3 and then 3 comma 1, but if j now is I is and this is j, now when I becomes 3 and j becomes 1. Okay, so this basically we have checked this condition, so we don't want to repeat it. That's why we have put this here. Okay, got it?
Yes, sir, got it.
Okay, so the other thing is now there is adjacency matrix. Okay, you can apply loop, etc., etc., but looping is not a solution. We have a matrix, we should solve it using some mathematical equation sort of thing, so that it gets solved just like that without doing anything. So the formula gets improved to enhanced to this thing 2 by E. And why 2 by E? Basically I'll tell you later on. Okay, so just first just keep this thing in mind. If this value, just for time being, just keep this thing in mind, we are just counting it. So there's only one edge, which is a1 comma 3 is 1, a3 comma 1 is 1. Okay, so 1 dot 1 is 1, but if I take a1 comma 2, that is 1, but 2 comma 1 is 0, so it becomes 0. So answer will be ultimately 1, summation will be 1. Denominator we'll discuss later on. First let me write this equation. Okay, trace of a square. This is another
Some
equation.
voice is there in the background, so some voice is disturbing.
People noise or white noise type of thing?
Sir, it's fine for me.
I don't know. I can't
Okay,
hear
sir, I'll
anything.
check.
Okay, anyways, I'll speak louder. Okay,
Yeah, no, sir, now it's fine. Here,
it's
now.
fine. Okay, ठीक है, चलो. So, what is matrix A? Matrix A is basically adjacency matrix, which tells if A is neighbor of B. Neighbor of B. Then what is A square? A square tells if A is one hop neighbor of B. So there exists another node. Similarly for A cube. A cube tells if it's a 2 hop neighbor of B. Okay. So A square means that can we trace the path if node A, basically to find the trace, to basically what does this part do? What does this part do? This part does that it checks if A is a one hop neighbor of A. So if there exists any path like that, okay, got it?
Yes, sir. Got it.
Okay, so now we have calculated trace. So what is the issue is we cannot just use the value directly. We have to make it a fraction type of thing so that we can compare it against another graph or something. Because the nodes are different, the values will be different. The size of graph will affect the value of reciprocity. Anyways, so what they do, what the formula is used is, so this sum, and yeah, sorry, my bad. Okay, what does trace do? So if trace basically sums diagonals of matrix. So if A is one hop neighbor of A, this means the diagonal entries of this matrix will be one wherever it's one hop neighbor of A. Okay, so A square will be something like this if reciprocity exists. So it is basically summing up how much ones are there. So this is basically this trace part will give us sum. Sum is fine. Okay, got it. Now what to do? What shall we put in denominator? Okay. So first of all, we half this trace. We half this trace because 1 comma 3 and 3 comma 1 is getting counted twice. So that's why we are halving it. So now if we do it for this graph, okay, so trace A square will become 2 because it will show for node 1 it will show this path, and then for node 3 it will show this path again. So we divide it by 2, then becomes 1. Okay, now what shall we do? Next thing is we make it a fraction type of thing with respect to graph. So ultimately what we do is we divide by number of nodes or number of edges. We do something like that. So since this relationship is number of edges only, number of pairs or something, so we will do number by number of edges only here. Okay, so we have got 1. Okay, we can simply divide it by number of pairs. Number of pairs are 1 comma 2, 1 comma 3, okay, and then 2 comma 3, 2 comma 3. Yeah, 2 3 edge is existing, 1 3 edge is existing, this is existing. Okay, so you can divide it by 3. But what does this equation mean? It's saying divided by e by 2. Divide trace a square 1 by 2. Just divide this thing by e by 2. Okay, so what is this e? This is number of edges, or what is it exactly? The formula for trace total number of pairs. Okay, so this is basically total number of edges out of that pair. So e by 2 is total number of pairs, but e is total number of edges. Okay, so if I take this graph, total number of maximum edges. The maximum edges in a directed graph 1 2 3 1 3 2. Okay, it is like this right now. So maximum edges is what? Maximum edges is this. A fully connected directed graph looks like this. Okay, so this means every pair is reciprocal pair. Okay, so what we do is 6 by 2, 1 2 3 4 5 6. 6 by 2 is 3, 1 by 3. That's how this formula works. Got it?
Yes, sir.
Okay, any other doubts? Manjula, Shikha, any other doubts? Basic. If you want, otherwise we'll start with the coding part. How to basically analyze network data, and I'd want you guys to please listen because I will be discussing some of the important concepts. Okay, I think I should close my iPad now. So So what shall we discuss, Manjula, Shikha? Any coding thing? Anything else?
Yes, sir. Related to social network analysis and how to that will be helpful for the research, and so you can guide us how to research and which will be effective, and it should be useful for the society in
Okay.
such a way. Yes.
Okay, so what I can do is I can start with some basics, basic data set. Just a sec. I can start with basic data set and I'll show you how the social network analysis thing is performed on that data set, how community detection is performed, and how communities are existing inside it, etc. etc. It won't be possible to finish it today, so some of that part might be extended in the next session. Okay, so Shikha, you want to discuss that?
Yeah, yes, sir.
Cool. Then let me just share my screen.
So will you be taking like already existing graph, or
Already
you'll be
existing
create?
graph, already existing graph. I won't be creating
Okay,
anything.
okay, okay.
I cannot create a graph just like that.
So
Uh,
can you like share the links for?
I will share it. I'll share it.
Okay, okay.
I'll share everything.
Actually, I downloaded that Cytoscap
Hmm?
and Cytoscap tool, it's an open source tool which
Uh,
is used for analytics. But I am not able to upload my YouTube comments or something, and I am not able to identify how to identify the communities in that. So I don't know. I just I stopped there.
okay, just a second. Just a second. My screen is visible.
Yes, sir.
Okay.
Yes,
Anyways,
sir.
let's do it on Google Colab. Google Colab is best. I don't have to worry about installing stuff. Okay. So let's go to Snap Stanford. Snap Stanford is very large project of graph, etc., etc. You can just find data set here, and they are already created in perfect in coordination with our libraries. Okay, so you can go to data sets. There is number of nodes, number of edges. Very large graphs are there. This is ecograph of Google. This is Twitch gaming graph. This is undirected. So if you want, like, what shall we do? Take a medium, large, whatever we want.
So do they also have the memory required for loading the graphs? Like, is it in GBs or is it in like MBs?
It's in GBs. Some
GBs.
of
Okay,
them are
okay.
in GBs. You see this graph, na live journal. Let me show you. Hmm. Um, so it's already zipped. Okay. So it's like 119 MB, whatever it is. Okay. Take this graph. This will be big. The metadata basically, it's not the edges. Number of edges can be contained in MBs. It's the metadata which is heavy. Okay.
Okay, like the node features and those
Yeah,
kind of.
the edge feature, node feature, definitions, etc., etc. So let's take
Can you
something like,
share this link, sir? Can you
yeah,
share this?
sharing.
Is everything open source now, sir?
Yeah, everything is open source. Okay, so see, I will use this YouTube dataset. It has a lot of nodes, literally. We might not be. Let's take something small, because that memory requirement will explode otherwise. Colab might not be able to handle it. and the printing stuff, plotting, etc., will take a lot of time. Let's take this.
Sir, actually, I have found that Kaggle is better because it gives, I think, some 330 GBs of RAM.
It gives, but I agree with that. But what I prefer is I prefer Collab in the sense Kaggle has a lot of disconnection issues. Like the connection gets broken between.
Okay,
So
okay.
if you are like basically you can run an script in background in Kaggle and it will be done. So that way Kaggle is good. You can just write code, run it in background, but that thing cannot be done on Collab. Anyways, let me just download some small data sets. Say this one, email EU core. It has 1005 nodes, 25,000 edges. Communities are 42. So I'll show you the 42 communities here. Okay, so let me download it. So it's a txt file. Okay, let me upload it here. It's connecting to runtime. Okay, it's connected. Let me upload the file. Okay, so I will start with network X. So see, this file has edges, and let me check if it's a directed graph or undirected graph. Okay, as per them, it's a directed graph which has communities. Okay, so we have to make it directed only. So nx dot die graph, let's initialize it. G is equals to nx dot die graph, add edges from a file.
Sir, actually, I found that using Gemini or some AI, we can get the code snippet.
I use ChatGPT, but I
Yeah.
prefer using this stuff because it's classical
Errors and
and you
everything.
also get to know a lot of other things. So you just don't have to worry about the point. Basically, this documentation thing helps a lot.
Right, right.
Over the time, you don't have to remember and you don't have to search it. You just get to know from documentation itself. It just starts getting stored in mind. So I still prefer this classical thing. I use it when I don't have time to do that stuff. Okay, so they are basically saying just read the file and then import it. So last time I told na first session or something. Okay, let's read txt file using read lines. So read txt file in Python. Okay, I'll go step by step. Let me open this file in read mode. What is this person doing? File.read. So yeah, this got printed. Okay, file1 dot read line. For line in file1 dot read lines, print line. See, it's giving us lines. Okay, so now what we have to do is we have to basically append them in the form of edges is equals to this edges dot append line dot split whatever this tab or thing is. This is a space, I guess. 0 1. I'm making it as a list of tuples. Okay, so we have got edges now. Why is it acha? Let me check. Line dot split 0 and 1. Okay, let me run it again. I think that buffer got empty. Yeah, buffer was empty. Okay, so let me just add it together so that these things are run as it is. So first let me replace backslash n with simple thing. Okay, so your edges are like this now. Are you guys there?
Yes, sir.
Okay, so this might start boring, but it will take some interesting turns. Just wait for a minute, okay? So either you can do this, you can ultimately convert them to integer as well, but let's just use as it is because we are not performing some mathematical operations on them. So now g dot add edges from edges. Now g, let's print g. Print g. It has 1005 nodes and 25,571 edges.
Is this a live node and result, Master?
Sorry?
Is this the edges, the connections, and all? Is this live and
Live in the sense?
that means is it connected now? Like that, I'm not able to understand how these data sets are really. What are the nodes and which?
See, let me just show you edges, okay? Let me just show you top 5 edges.
A little bit. I need maximize that. Codings are very small.
As much a font is small.
Yeah, now it's small.
So edges are like this: node 0 to node 1, node 2 to node 3, node 2 to node 4, node 5 to node 6, node 5 to 7, node 8 to 9, 10, 11, 12, 13, like this, okay?
So the dataset does not have any features. It just
It,
has the.
it doesn't have features, but it
Okay.
has one thing. It has one thing, let me show you. It has some labels. See,
Okay.
department membership labels. I'm not going with that because that is basically used for proper analysis sort of thing. I'll show you that later, but first that part will come later. That will take time to reach there. I'll show you labels exactly how the labels are there. Okay, see. So for they are say they have 11, 12, 42 communities, something like that. Okay, so each
Okay.
node has been mapped to a community. Node 52 has been mapped to community 137, 24,
Okay.
like that. Okay, so this is 41. If you search 41, you will find the 41st community here as well. So these are basically communities mapped against number of nodes. So 1004 to 0 all are mapped to one community. Okay, so see, community number 1, 0, 1. 0, 1 was the first edge. Then 17, 18 might be connected to 0, 1 because these nodes are not. Okay, so community 1 is very small, I think.
Okay.
I don't know. Let's see. Let's see.
Yeah, how to see that nodes features and
We'll come to that
is
later
it
on. We'll come to that later on. Just first, just see the graph, okay? I don't want to
okay?
worry about what features a node has. It because this dataset has nothing. This dataset has nothing about features of edges and nodes. It just has this just has community information, okay?
So
Okay.
this 1 and 14, that means 1 belongs to that 14, that community. It means
Yeah,
like that. Huh?
yeah. That one comma this is basically edge. 12 and 13 there is a directed edge. 12 and 14 there is a directed edge. But that file, this file,
Sir, what is this data set? Like what the nodes represent and the edges represent?
users email, they are basically
Okay, okay,
email
email. Okay,
data set between users, so they are basically forming communities between users based on the email communication amongst them.
okay.
Okay, so say you have this data set. Now what operations are there? What operations are there? I'll just go through book and I'll perform each and every operation one by one, and I'll show you how these things are relevant. Okay. Mhm. So first of all, let's start with network measures. Network measures, uh, there's degree distribution. I'll show you the node with highest degree, okay, because that node might be the part of some big community. Okay, so nothing, just go to Google and search. Okay, um, degree of a node in network X. Okay, so this is basically graph dot degree. If you do g dot degree of 0, I think I've taught all this stuff. Okay, anyways, g dot degree of say node 2. Node 2 has degree 161, and it possible that, see, node 0 and node 1 might have small degrees, but these nodes 2, 2, 5, 5, node 5 will have a very high degree because it's repeated in the top 10 samples, it's repeated twice or thrice. So that basically tells, sampling basically tells very a lot of things about the graph. Okay, anyways, so we can check the degree using this stuff. Okay, the next step is degree distribution. So if you want to see degree distribution, so let's see degree distribution. Okay, so see this, the degree analysis they are performing. They are plotting some stuff using this. So this graph basically tells how many nodes are there with how many degrees. So I can plot it if you want. Okay. So in network X, in this stuff, don't worry about g dot degree. The graph is g, na? Let me make it g. Don't worry about the code. Okay, the code can be written anyhow. There's not an issue. Okay, let me just fix this first, then I'll show you what they are doing exactly. And this graph, this thing, not implemented for directed type. Okay, okay, GCC connected components. No, I don't want to say this thing. I want to see this thing only. Okay, so see, we have 1000 nodes. Hello, am I audible?
Yes, sir. Sir, what is the highest? Is it like 500? Okay,
See, no,
okay.
this degree is 500. There is a node. There is only, I think,
More than
five.
500.
Yeah, there is for one, two nodes. Or this if we just zoom in, scale it, then we will find one or two nodes with degree 500. So this means that node is getting connected to 50% of the data. There,
Right.
there are 10,000 or 1,000, 1,005 nodes. Na? Yeah, it's getting connected to 50% of the data. So that node might be a part of very big community, or it might be not a part of big community, but it can be a bridge between communities. Okay, so we'll observe that as well. say there's this node will be a CEO. This node will be CEO. So CEO basically emails you every day to all the employees of a company. Okay,
Right. Mm.
this node emails all the employees of a company, so it has very high degree. It is connected to everyone. And
So here it shows that probably 10 nodes consist of this
sorry,
10 nodes actually. So 10 nodes have 80 degree. That means some 80, 10 people are connecting 80 nodes
which
right
one
now
are you saying?
based on that histograms.
Yeah, say this there this I'm going backwards. Okay, so this is one
Yeah.
node. This is one node. This length may
Okay.
be one or two. It has degree 500, so it's connected to 50% of the employees somehow. So this person might be the CEO of the company. They are communities, but this person is a part of each and every community somehow. So that's like say you have different teams working on different projects, but this person handles everyone, so it's connected to everyone. Then this node, the 30 nodes, more than 30 nodes, have very high degree. That high degree of say this one or two, whatever it is, I don't know. Not high. I will not say high degree, but these number of like this follows basically up what scale this is Pareto law or something. Pareto law basically says 80% of outcomes come from 20% of causes. So you see here, 80% of the degree, okay, sorry, 80% of the nodes have 20% of the degree, something like that. Basically, this scaling, that three conditions are there for the real world network. The scale, they are scale free. Okay, they have local clustering coefficient, high local clustering coefficient. Then they follow power law. Okay, let me show you power law. Power law is the correct one. Yeah, power law is something like this, and this graph is also following distribution like this. So this is a real world graph. That's why it is following this distribution. Okay.
Sir, is it email network of a company or like a college or something?
It is EU. What is EU? EU. Where is it? Where is it? Community, community, community. EU. Yeah, it's written here. See, large European research institution. We have anonymized information of all coming nodes. There is a edge between if the person has sent at least one email from to person V. Email only represents communication between institution members, and data does not contain incoming messages or outgoing messages from the rest of the world.
Okay.
These are only within institute network. Okay.
Okay. Okay.
This ground truth contains the community to which that basically department or community to which each node belongs. Okay. So ultimately, we will see this is ground truth of department, and we will see by community detection that around 40 to 42 communities are getting formed. Okay. This is the basic stuff which they give. So node with node in the largest uh, what is this W SCC is giant component or something. Anyways, let's get back to the code. Okay, so this is following power law. Am I audible? Yeah, this is following power law, and this is what most of the real networks follow. So degree distribution is basically telling us the power law thing. Okay, now we come to the next part adjacent node indices, walk length, etc., etc. This stuff is not. Oh, was joined. Yeah, so adjacency, this stuff is not relevant, but average path length. Okay, let's compute average path length. So average path length will tell us many things here. Network X average path length. simply do this. So see, very interesting thing, very interesting thing we got here, and I'll tell you why it's interesting. Okay, let me just. Hello, am I audible?
Yes, sir.
See, so average shortest path length can only be found if the nodes are connected. Okay, so if they say this graph is complete connected, this is connected, but there exists no edge between these two graphs, so you cannot find the average path length in this complete graph. So what it is showing is these departments are existing independently in an institution. Okay, there is no interdepartment communication between these departments. That is why some of the departments are not connected and this graph is not strongly connected. It might be weakly connected, but it's not strongly connected. Okay, secondly, this person which has a very high degree, this is not communicating with all the departments. Otherwise, if this node was part of all the departments, then this graph would have been automatically be fully connected or strongly connected. But say this
Right.
person does not communicate with all the departments, so this means this person might not be the in charge of the institution. This person might be the in charge of some of the departments, so that is why it has very high nodes. Okay, or or say there's a department which is very huge. Okay, so say there's Amazon AWS department which is very huge compared to Amazon Alexa department. So that person, that department's head might be communicating with more than 500 people, but Alexa department has only 20-30 people, so it's not communicating a lot. Okay, so this might also be the case for these nodes, for these spikes here. Okay, that is why this graph is not fully connected. So what does this thing tell us? This thing tells us even though the degree might be of one or two nodes might be close to half of the number of nodes, but this doesn't mean the graph will be fully connected. We cannot assume it. We have to check it like this. We have to check it. So if the graph is fully connected, we will find some value for this. Okay, so what we can do is we can find the giant component and then we can compute, but it does not make any sense because the giant component might be department specific. Okay, anyways, um, density, let's check density.
Sir, so using average path length, we can check whether a graph is connected or not.
Yeah, this is one way. There are other ways as well. Okay,
Okay.
if you search ChatGPT, it will tell you 500 ways to search that.
Okay.
Okay, so even yeah, this thing also.
Right, yeah. In
Network.
collab. So,
Yeah, let me just do this stuff. Network X, check if the graph is fully connected. See, is connected.
okay. Okay.
It's saying not implemented for directed graphs. So this is the problem. You have to write if
Directed.
the directed graph is fully connected. Is strongly connected. Yeah. False.
False.
So if we cannot directed, basically a graph is connected if there exists an edge. Okay, there exists an edge
Right.
between A and B. So but in directed graph the edge is like this. Edge is like this. So it's fully connected. Directed graph is fully connected if the edge is like this. A to B. Uh, A to B. Sorry. And then B to
To
A.
A.
Then it's fully connected. So that's why this component, this thing is both said as strongly connected, and this is said as fully connected in case of undirected graphs. Okay, Manjula, you're getting it.
Yeah, yes, sir. Yes, sir.
So interesting stuff. Interesting use of Google
Yeah, it's
Colab.
very nice because I don't know that prompt typing.
That
Actually, now only
I,
I
I
need.
I used to use it, but it has been a long time, and now I'm using it, and it's very interesting.
It's
So
very helpful.
so it also gives you, basically you can this notebook. If I write this code like this, na, so this will automatically contain this comment. So and the person reading it can immediately think what this code says exactly. Okay. Anyways, uh, so this is done. This is done. We have computed it's strongly connected or not, etc. etc. stuff. Now let's compute the clustering coefficient. Okay. So local clustering coefficient should be high. And what is the meaning of high?
So there is a connection between that node.
No, no, no. What value exactly means high?
One.
What value? Like,
Degree greater equal to 1.
yeah, basically it's around, in real world, it's around 1.5.
One.
So compute local clustering coefficient of graph, directed graph. Let's get used to this convention of writing directed graph. Okay. So it is computing it for every node. See, for every node it has computed. And that is what local clustering coefficient is about. Local clustering coefficient is for each and every node. It's global clustering coefficient is for the graph. Okay. Getting it? Hello. It's
Yeah,
Yes, sir.
yes.
it's a node level feature, but global clustering coefficient is a graph level feature. Let me close this. Let me just retract
So
the.
it indicates that zero node is having this much of clustering coefficient
Yes,
and this and
yes.
that are one, two, three.
See. So global clustering coefficient is basically transitivity because it connects triplets A to B, B to C like this. If you have studied it, it checks how many closed triples are there and in a graph and divided by total number of triples. Triples means open and closed. Okay. So if you do this, you will get a single value. Okay. So because this is a graph level feature and global clustering coefficient is not a part of that three rules which define whether a graph is a real world graph or not. Okay. So now coming to the interesting part, what how many connected components are there, how many strongly connected components, etc. etc. Okay. Find connected components in directed graph. List them. Okay, it will list them simply. So very huge list. See, node 1 is independent. These nodes, they are not, they are basically, I think they are the head of the community. This is something like that. Okay. So it, let me check what type of output it gives.
And
Sir, I guess this is where the AI fails.
Yeah,
It
this is where
can't.
AI fails.
Yeah.
AI has very bad use cases in this
it
scenario.
is very
Anyways,
helpful.
use cases in the sense like it's making life easy. If you ask someone to code during interview using Google Colab or something, they can simply generate it in front of you.
Sir, you share save this Python program in Google Colab and share this program to us.
I always share it. See, I'm showing it again. I show it in every doubt session. This is the drive link. Okay,
Oh,
this
oh.
is the drive link where everything is getting saved. Whatever we discuss under the name this collab PDF. If you just want to read it online, you can just scroll and read it. Okay,
No, not PDF. That Python
it's also
program
there.
itself.
It's also there. See, for every week, it's there.
Yeah. Okay, thank you, sir.
Okay, so yeah.
So So, what are the various insights we can get from identifying these kind of things? Sir, can you say some example?
I'm showing,
And
I'm
in
showing that.
real time,
That's why
in
that.
real,
Just a second, just a second. Let me speak. Okay. That's why I don't take big graphs to explain, because then visualization is very difficult. Now you cannot see what I wanted to show you because this is very big. Okay.
Sir, can we check it in Gephi or Jeffy?
I can
So,
check it. We can check it. It's not an issue, but then ultimately we have to just sit and waste time importing here and there. I have used to have Jeffrey. As yeah, it's there. I need to install it again. Okay, let me show you on Jeffy as well. Both the things combined. It's visible, right?
yes, sir. Yeah.
Okay, so let me go to file. Let me open this. Just a second.
so JP also open source, right, sir?
Yes. Okay, okay. So in downloads, what was the file name?
I think email you something.
Email you. Okay. Email you. Okay, open. Just a second, let me open it again. The problem with Jeffy is this just not usually takes txt files. It cannot take txt files directly. It takes csv, etc., etc. Anyways, just leave it. It will take time. I will show it after this thing is done. Okay. So basically, what it's telling is strongly connected components are those components. Uh, if there's a directed path for every pair of nodes in G, so node 1 doesn't. Let me start with weakly connected components. Let me check if it's working or not. Yeah, now this is interesting. Okay, so it just shows for the nodes which are connected somehow they are connected, and it does not have a lot of communities. Say these are disconnected nodes, they are not connected at all, but these are connected to form somehow communities. Okay, these are connected to form somehow communities. Strongly connected checks if there's a link between 0 and 1 and 1 and 0, like that. So if I do is weakly connected, you will find something like this, where all the nodes are connected except the ones which are not connected at all. And this will show you if there exists a path, there exists this pair type of reciprocity set type of path between them. Okay, so there are very few nodes like that. um,
Sir, the curly braces represent a community, is
yes,
it?
they represent a community.
Okay.
Okay, so see 0, 10, 100, 1000, these nodes are connected. There exist die edges, like uh, the closed loop by type of thing. So one is communicating with 10, then 10 is also communicating with 0, 0 is communicating with 10, and then 10 is also messaging him. Okay, 0 to 100, 100 to 0. This directed edges exist between these two. Okay, so what might be the case that node 0 might be very huge, something like that, or some of the other node, and they are communicating to and fro. That's why this is the largest community here.
Sir, I have one
So
doubt.
that zero comma comma, so that means that all nodes are connected now, sir.
Yes, yes, yes. Till
It's like
999,
PQ.
from 0, they all are part of one community. not community, basically one giant component. Okay.
Sir, there are like one single node in a curly bracket. What does it mean? Only one node in that?
No, no, no. Yeah, basically it does not mean that. It means 693 had emailed someone. That person has not emailed them back. So 693 is not a part of any other component, giant component type of thing.
Okay.
Okay. So if you do that's the just you do just this thing, weekly edit component. So this includes all the nodes except these nodes, because these nodes might not be connected at all. They have not emailed anyone right now.
Okay. Like
Okay.
isolated
Yeah,
nodes.
they are isolated. There's no edge exists between them and this community. So that is why weekly
Okay.
communities, weekly connected components are not checked for a directed graph. Okay. So next thing is centrality. We can do centrality, or we can check the giant component.
So
Giant.
if it is only one node is there, then how can we say that one has strongly connected component?
Where is it?
It has to
It's not
count with
strongly
some
connected.
other node, right?
It's strongly connected. It's not a component, na. It's just one node. They have to print everything, na. That's they cannot leave the nodes out.
So can you explain? I'm not able to get that.
Yeah, me too,
This
sir.
this is not a giant component. Okay, this is not a very big, fully connected giant component. It just shows these nodes are individuals. They are not part of any community right now. Okay, they are part of their individual communities right now. Okay, they are not connected. They are not part of any giant component or any component, but ultimately it has to return. Basically what it does is this function is performing operation that checks this reciprocity. If the reciprocity is not existing, it's returning the label directly like this. If reciprocity exists between these two, this node and any other node, then it would have returned it like this, 1 comma 3, and that would have been a part of one strong component, because 1 to 3 there is one edge, then 3 to 1 there is one edge. Getting it?
Sir, one doubt.
Mm-hmm.
In the weekly components, we have single nodes, and
Yes.
also in the strongly connected. What is
Mm-hmm.
the difference between those?
You said na sir that's only
Okay.
one node is
Stop,
there means that
stop,
is
stop,
weekly.
stop. Let me share my iPad.
Okay.
Okay.
You guys are not confused. You are not just visualizing it, okay?
Yeah, yeah, yeah.
Don't
Yeah.
just before doing this stuff, before doing this whole coding part of thing, imagine imagine the graph in your head, and that will only come when you visualize small graphs. But if I had visualized small graph, these giant components, etc., these would not have been visible. So that's why I ask you to practice this thing. Okay, take small graphs from this website, do this stuff, check out, visualize it, plot the graphs, etc., etc. Anyways, just hold on a second. Let me connect my iPad. Okay, so if you have any doubts for in assignments, etc., just email me before a week, or like before 2 3 days before, so that I can prepare it in written writing. Otherwise, what happens is if you ask me immediately, then I have to search for solution. There's if Mega has uh, created that assignment, then I have to ask her. So that becomes headache for me to arrange immediately. What happened? It's taking a bit of time. Just wait a second. When do you guys have your exams, midterm exams? Hello?
So you mean the
Yes, sir.
course exam?
Yes, course exams. Not this,
26th October, I
not this
think.
NPTL. Your college
Okay.
exams.
Okay. I am not in college currently.
Okay, okay.
Exam in the sense you are asking this NPTEL exam, sir, or students exam?
A student exam. You are studying somewhere, na? So those exams.
No, I will not study. Working, sir.
Okay, okay.
Yeah, same.
I'm studying now. I have exam on 17th.
All the best, sir.
Thank you.
You are studying, sir?
I'm doing PhD.
Oh, where, sir?
IIT Delhi.
How was the college?
Mood
Good.
question, like I can say a lot of good things and bad things together combined. It's overall good, overall worthy in the sense worthy of PhD. Like people generally prefer going outside, na, to come do
Uh,
PhDs. But
Sir, in
I,
which area you are doing, sir, PhD?
yeah, sorry,
In which area? Social network, huh?
yes, social network only.
Can you say about your topic?
My topic is basically graph expansion, synthetic graph expansion over time, and how to basically what Albert Barabasi did. I am doing it in smaller scale. So, so you have already existing graph. You want to expand it, but now I don't take graph in consideration. The degree I take features in consideration as well. So where the node will go will depend not just on the degree of the node, but also on the features of the nodes, the textual features, etc., etc. Anyways, let me show you example. This thing means it's the directed edges in both directions. Okay. So when I make components, so take I'm taking this node. Okay. This node is connected to this node in both directions. Okay. So this is 1 2. So one component will be 1 comma 2. Okay. Then 2 is connected to this again. See, 3. Okay. Hello.
Yes, sir. Yeah.
Hmm.
Okay.
But 3 is not connected to 1 anyway, but that does not matter because I can go from 1 to 3 and 3 to 1 without any issue because this path is also here, this path is also here.
Sir,
Okay.
which node is 3?
This
Uh,
one, sorry, this one. 3,
okay.
4. Okay. So I cannot take node 4 here because 1, 2, 4 I can go, but 4 from 4 to node 1 I cannot go. Actually, I can go, see, I can go from 4 to 3, 3 to 2, 2 to 1. Okay, so 4 is also a part of this community. Getting it?
Okay. Yes, yes. Yeah.
Okay. But now what I do is if I remove this edge, I change the direction to here. Now the community will change. Now the community will be 1, 2 and 3 only. 4 will, and then other community will be 4 only here. 4 is not a part of this community because I cannot go from 2 to 4 and 4 to 2. But had this arrow been in this direction, I could have gone from 4 to 2, 3 to 4. I could have gone from this direction, 3 to 2 to 4. So the path, if there is a proper path, then this component is strongly connected. Okay. Hello.
Sir, can you explain the last part? Like, if there is a path, then.
Let me just draw it again.
So if it is connected all
Wait, wait,
both the way.
wait. I will draw it again. So this was connected. This was connected. This was connected like this, and this was connected like this. No, sorry, like this. One, two, three, four. So let me start with one. From one I can go to node two, and from node two I can go to node one. Correct?
Yes.
So two is a part of this component. This strong component. Strong. This is SCC, strongly connected component. Okay. So this is node 5, 6, 7. Let it be like this. Okay. So if I go to node 3, node this is 4, this is 3. Node 3. Can I go from node 1 to 3?
Yes.
From 3 to 1?
Yes.
Okay.
Yes.
for node 4, let's see. Can I go from node 1 to node 4? 1 to 4 I can go this path.
So 4 also come into the picture. 4 to 3 and 3 to 4.
Oh no, just a second, just a second. Hello, hello, hello.
Yeah, yeah.
Yes, sir.
Actually, my internet. Just a second.
Disconnected.
Yeah, just a second. Actually, in IIT, this thing happens a lot. That's what I was saying. Some good
Okay.
bads or bats of IIT. Okay, see. From node 1 to 4, I can go by this path 1, 2, 4. Correct?
Yes.
From 4 to 1, I can go from this path 4 to 3, 3 to 2,
3 to
2 to
1.
1.
Yeah.
So 4 is also part of this strongly connected component.
Right.
Then there are these components node 5, node 6, node 7. Correct?
Okay.
But what happens if I reverse this edge? Now let's make SCC.
Sir, we should not write 1, 2, 4, right? No?
1, 2,
Because there is no bidirectional in 2, 2 and 4, right?
2, 1. No, no, no. 1.
So, is
See,
it possible to write the community 1 to 4? No, right?
where in this second case?
In this graph, 1 to 4
Yes,
is not possible.
just a second, just a second. Let me explain. Let me explain, okay? So node 1 is there. I can go from node 1 to 2, correct?
Yes.
Node 1 to 3 I can go.
Yes.
3 to 1 I can go.
Yes.
Okay. From node 1 to 4 I can go.
Yeah.
Yes.
But I cannot go from node 4 to 1.
Right.
So it's not a part of community. This strong component, okay?
Sir, why you, sir,
Sorry?
sir, in the first statement you have said, na 1, 2, 3, 4 is there possibility.
Arey, arrow was in this side, na then.
Couldn't get it.
It was another graph.
Earlier the graph was this. Now the graph is this. Arey, I'm lazy. I'm not drawing it again. Just a second. Let me draw it. Otherwise you will be confused. Let me just copy paste it.
You erase the arrow.
Yeah, just a second. Okay, now let me reverse the arrow. See,
One. Oh, yeah.
so now from node 4 I cannot go anywhere.
Yeah, got it.
This is what the output was.
Sir, this is clear. Can you explain the weakly connected components?
Arey, I'm just you got this. You got this, right?
Yes. Yes.
Okay, so weakly connected is nothing. Weakly connected is WCC is simply remove this thing. Let me draw it again, otherwise you will be confused again. Okay. Convert your directed graph to undirected graph. Okay. And now perform, now check connected components, and that will be WCC. So now it's 1, 2, 3, 4, 5,
6.
6, 7. Simple. So for this graph, WCC is same as SCC, but for this graph it's not same because the direction matters. Okay.
Got it, sir.
Great. Okay, so important thing. The thing is, doubt should be clear because I cannot proceed further without clearing this stuff. This is very basic stuff, and later in the course, abhi community detection, after community detection as well. If you're not getting this point, then there's no point of understanding communities because a strongly connected component itself is a part of community. Okay, if the links are already broken, it's a part of different community. So you just have to imagine this stuff inside your brain. From now onwards, if somebody asks you what is a strongly connected components, you can simply say you can reach from one node to any other nodes without worrying about the length of the path. The path length can be any long, it doesn't matter, but you can reach from one node to another node. If you cannot reach, then that node will not be part of strongly connected component in case of directed graph.
So if there is no direction is present, then it is weakly connected.
Array,
So this one you please explain, Meena.
see. In case of undirected graph, we simply check if this is a connected component or not connected component. Okay. Hello.
Yes, sir. Yes.
In case of undirected graph, there are two things. There is
Connected and
connected network and disconnected network. But in case of directed graph, we cannot simply say like this because the connected network, this connected network in case of the undirected graph will not be similar to what in this case of directed graph is there, because directed graph has directions. Those directions matter. They are of some use. That's why they are there. We cannot simply use this notation of connected network in directed graph. So that's why we have defined two other notations: strongly connected component, weakly connected component. Weakly connected component is by converting your directed graph to undirected. But this does not mean this weakly connected component is not equal to connected network, because then this will mean this is an undirected graph. It's a directed graph. We are just ignoring the directions. We are doing it without considering the directions in our mind. Got it? Hello?
from strongly connected to weakly connected, we have to remove the directions.
Yes. So that it
And
becomes undirected graph, and we can simply perform whatever we were doing. In case of undirected graph, we will do in on this graph, but we will not call it connected network. We will call it weakly connected component, so that we can differentiate the notation so that it's easily understandable that it is for a directed graph and not for an undirected graph.
it's a little bit confusing. So,
If I say
one,
just
see,
let
1, 2, 3, 4 is connected or not connected.
it's connected.
There is no direction. Right?
No direction. Let me speak something. If I say I have a graph, it is a connected network. What can you infer from this sentence?
So connected means there is a direction. That means
No,
you
no,
can
no,
go
no,
from
no,
that
no,
one
no,
node to
no,
another
no,
node.
no. There's no direction.
Yes.
Okay. If I say there I have a graph which is connected network, it means that all nodes are connected.
Yeah.
Let me show you a photo in book. Where is that? Yeah, here only. No? Can you see my image, my screen?
No.
Okay.
No, sir, it's very blurring.
Ah, I was trying
That
something.
is social network analysis book, na?
Yes. Just a
Can you
second.
say the page number? I bought that one.
Page number 53. Now is it visible? Hmm.
Yeah.
Shikha, is it visible to you?
Yes, sir, it's clearly visible.
You can see there are three disconnected components.
Yes.
Getting it? This is one component disconnected. then this is one disconnected component, then this is another disconnected component. Getting it?
Actually, is the meaning of weakly connected. That means what? That nodes are not connected.
Nodes are connect. Let me first say. Wait. Don't get confused in the notation. So whenever I say I have a graph, okay, it is fully connected. It is a connected graph. Okay. Hello.
Ah, yes, sir.
If I say I have a graph, it's a fully connected graph, which means that there exists a path between each and every node. I can go from any
Yeah,
node to any node. But
yeah.
since I'm saying it's a connected graph, I'm not, it means it's an undirected graph. Okay?
So we should not consider the direction.
There is
Directed
no
graph is
direction.
not considered for this one weakly connected.
Yeah. No. Directed graph is considered for weakly connected graph. Just let me hear first. Let me speak. Let me speak. Hear me, okay?
Yeah, yeah.
Okay. So I'm saying I have a connected graph, I have a connected network. What can you infer from it? You can say, yeah, from one node you can go to any other node. There's always a path, there's no disconnected thing. You can always go irrespective of the length. Okay?
Yeah.
But it also says one thing. What I'm talking about is an undirected graph. My notation is this. These three terms are notations. They are just used to represent three things of two graphs. Okay? Now, when I say I have a strongly connected component, I have a strongly connected component of a graph, so you can simply say, yeah, in this strongly connected component, you can go from one node to any other node following the direction given because it's a directed graph. Correct?
Okay.
But when I say,
Just
sorry,
just tell me about weakly connected
yeah,
component.
I'm telling. But when I say ki I have a graph, okay, this component is not strongly connected, but this component is weakly connected. This means I cannot follow the directions of arrows to reach from one node to another, but if I ignore those directions of arrows, I can go from one node to another node. Getting it?
Sir, I got it. It's like edges are there, but path is not there.
Just ignore the no path is direction arrow direction is not there.
In weakly connected.
Yeah.
Yeah.
This does not mean we have removed that direction. The graph is as it
Right.
is.
Yeah.
But we are just assuming that that direction is not needed. Say, let me explain by example. Let me explain by an example. Okay. Uh, cyber security type of thing. Okay, cyber security type of thing. Let us assume I am a scammer. I'm a scammer sitting in India. Okay, I'm trying to scam people in USA, and say you guys are working in FBI. Okay, and you want to trace the money. You want to trace the money which has which has been deposited in my account from the victim's account. Got this thing?
Okay.
Okay. So what I'll do is I cannot ask the victim to directly deposit the money in my account. What I'll ask him or her or whatever the person is, I'll ask them to deposit the money, convert the money in bitcoins. Okay, send bitcoins to say Switzerland. Then Switzerland bitcoins will be sent to Turkey. Then Turkey bitcoins will be sent to Russia, and then Russia bitcoins will be sent to India. And then I will be converting bitcoins to cash. You got the path?
Yes.
Okay. Now, you being an FBI officer, you cannot simply go to the person and you cannot simply come to me. You have to go through that path only. Okay? You cannot go from Switzerland to Russia directly. You have to use Turkey in between.
Right.
Okay? So, this means the direction is important to get the trail of the money. Okay?
Yes.
The direction is important. Getting it? But
Yes.
when you came to you just traversed through the path, you came to me, you arrested me. Okay. But once we will submit the report to your seniors, what you will tell? You will tell, okay, the person siphoned the money through these countries. You ignore the direction. You ignore the direction so that your senior can get it. Yeah, these countries are getting involved in some illegal stuff. In what direction? The senior does not care. So
Got
what the
it.
person will do is the person will stop all Bitcoin transactions to these countries, so that the victims cannot just deposit the bitcoins and send to these countries. So the person will stop transactions to these countries. So basically they are creating a barren border between the transaction. So this is what strongly connected weakly connected component is. It's just an intuition inside your brain. Okay, what you want from the graph. You wanted to catch me, you followed strongly connected component. Your senior wanted to just stop the transactions. It just saw where the line was connected, and it reached me somehow, and so it basically dissolved the relationship between those countries, and it saved the money. You got it?
Yeah, okay, sir.
Sir, like I'm thinking out loud here, but like if we take the example of say a virus infection, right?
Yes.
In that case also
Same
weakly
thing.
connected
Same thing.
component can help.
Yeah.
Uh,
No. 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 Actually,
yeah.
it. If you have infected someone, okay, that person might also infect you back
Okay.
instantaneously.
So
So
what if I take vaccines?
vaccines. I mean, that's why I took that example of scammer scammy, because
Right,
in
right.
that case the scammy cannot be a scammer.
Oh,
Okay, the
okay,
direction arrow cannot be pointed backwards.
okay.
Okay, Manjula got it.
Yeah, yes, sir.
If you have any other confusion, I can give another two, three examples like that. You okay? So it's
So can
ultimate.
you see
Please.
some definition in one line? How we can say that one as weakly connected component in one
Weakly
line?
connected component is a component of a directed graph. Must listen to me. Weakly connected component is a component of a directed graph such that all nodes inside that component are connected by are connected by a path or edge. Okay,
Okay.
and a strongly connected component is a component of directed graph such that you can travel from one node to any other node following the direction of edges. And a connected network is a connected network is a component in a undirected graph such that the edges exist between all the nodes.
So without direction, if their nodes are connected, then you can say that one is weakly connected.
Yes, it's the simple definition. Because sometimes we just don't want to give a damn about those edges. We just want to check if those all nodes are connected or not. Okay, you don't want to see whether Turkey was sending money to Russia or Russia was sending money to Turkey. They were somehow involved, so you banned both of them.
Okay.
Okay, just get rid both of them, let them transfer money to each other. I won't get involved in that stuff. Okay, so that's why we took the weakly connected component. But if you want to check what technology are they using to transfer money from Turkey to Russia, and from Russia to Turkey, those two technologies might be different, then you have to consider the strongly connected component to follow that money trail or path.
Okay.
Okay.
Sir, can I say that, see, there are four students are there. That four students are within the class only,
Okay.
but see, they can able to communicate with others, but they are not communicating, right?
So what? They
So simply, I'm
Yeah,
saying,
no, no, no. They
if they are
can.
not
There might be a
weakly connected,
case. Yeah, weakly connected. There might be a. They are not communicating, correct? But there might be a case that two students are fighting with each other. They will not communicate at all. Like node one and three here,
yeah.
node one and three here. Okay, they are fighting. They don't talk to each other, but they are talking to other people in the class somehow.
Okay.
So this gossip is getting passed to this person somehow.
So there is a path existing, but they are not communicating.
Yeah, there
That's
is
it, right?
no they might not be one hop neighbors, but they are somehow two hop or n hop neighbors. Like node
Okay.
7 cannot be any n hop neighbor of node 3, so it's disconnected component. Okay, but node 3 is two hop neighbor of node 1. Okay,
So only one doubt, in a weakly connected component, it is an undirected graph
sorry.
alone. The undirected graph alone, we can say that it is an
No, no,
weakly
no,
connected.
no, no, no. For undirected graph, we do not use that notation because undirected graph does not have the concept of weakly and strongly connected. If I say you have for undirected graph, you say this is a weakly connected component,
Can you
then
say in the previous diagram is there na? In that diagram itself, can you say this weakly connected component here itself?
in this diagram I can say yeah 1, 2, 3, 4 are weakly connected components because somehow they are connected by edges, irrespective of the direction.
Okay.
Okay. I cannot say the same for undirected graph because what will be the strongly connected component for undirected graph then? Because we do not have the directed representation of that graph. Got it?
It like both will be same, so there is no point in using strongly or weakly connected in
The edges,
undirected.
the strongly connected thing says the path should exist. Okay.
Right.
If Turkey is not transferring money to Russia, then what's the use of that path? Okay. Then they are not strongly connected.
Okay.
Okay.
Yeah.
It's just in notation. You cannot
Yeah.
compute SCC and WCC for undirected graph, but for directed graph you can, and you need to because you cannot simply use SCC and say yeah just because this arrow did not point downwards, I'm ignoring this connection. So there is a weak connection. Somehow there's a weak connection. Although the connection is not strong, but there existing a weak connection. I need to study that. Getting it?
Yes, sir. Yes.
Yes, clear, sir.
Cool. Any other doubts? Mm-hmm.
Yeah, that some of the models are little bit confusing, sir.
What model?
I think like WS model, those kind of
Acha,
things.
that thing. That thing is confusing.
Yes, 1 minute.
Sorry. Hello.
Yes. Ah, yes.
What is?
Yes.
Tell me exactly that thing. Na, I will teach you in next class then.
Yeah. Okay.
What is confusing? What is confusing?
That is, yeah, I think.
Just a second. Just a second.
Like similarity measures.
My Apple pencil fell down. Huh?
Similarity measures, na sir.
They are confusing.
Yeah.
Okay, I'll teach in next class because now we don't have a lot of time to teach that.
And also big clam method also confusing, sir.
Big clam, which chapter? Which week was that?
In week 6, lecture 8.
Week 6, lecture 8.
There is a lot of formulas, na.
They,
So,
intuition, just study with intuition first. Formulas come later. The whole
Yeah,
point of
that's
studying network analysis is just study with intuition.
seeing the formulas itself, we are stuck actually.
Just yeah, big clam. I got it. I got big clam. Array, it's simple. It just looks like very difficult. It's simple. I'll teach you in next class. Okay, just put an email on the Google group so that I can make notes of it.
How to connect with Google group and all in
You're not there.
forum? Is there any forum? Is there for?
Array, just a second. Let me present my this screen. Uh, 6 weeks have passed by. This is the 6th week, I guess. 7th week or 6th week?
Sixth week.
6th week. And you are now asking me, where's the forum?
We are not at all. Never we entered into the forum or
how do you-
even this online class itself. Now only we are attending. Previously we won't attend actually.
See this. See this.
We don't know actually.
This page you come to, na? This page week 1, week 2.
Yeah.
Q&A. Continue. Got there. Simple as that. Got it?
Okay.
Put an email there and then I will just make notes because I have to make you understand. For that I have to take an intuition analogy type of thing so that I can make you understand.
Yeah.
Because the book, the definition, they are very difficult. They're not difficult, but they are just probabilistic and logarithmic type of thing.
Yeah.
But they are just probability of an edge existing. That's all.
Actually, they said in the video we have to find out the similarity of that edges and all, and they have drawn the dendrogram and. But based on how we have to do that, actually, because we don't have that background of knowledge now, that's why we
Uh,
are struggling that one.
that's I'll teach you. I'll teach you in next class. Okay.
Yeah.
Just make a list of topics which you have confusion in. Shikha, you have doubts in any topic?
No, sir, not currently.
Okay. So whatever you doubt, you have just like email a day at like 2 3 days before, so that I can make notes of that, and then we can discuss it. Okay.
Yeah.
Chalo cool. Then abhi ke liye let's end it, and we'll see you next week with whatever doubts you want to discuss. I'll
You
share the
can
collab notebook.
you can give like a that I know what to say. The overall all that week. It's just a recap of overall, so that we will also have some hope. Okay, so whatever we understand, only sir is saying. So like
Which
that.
which week which week overcap you which week like gist you want?
See, if it is a week 6 now, so 4 days is there. So week 6, you can overall you can give me a glimpses. So this is what this. So this model is for this, and this model we are learning that, and
Okay.
like that you can give. So this is similarity measures we are doing, and all those things
So
like.
summary of that week 6 you want, right? Like type of that. Not just week
This.
6, all the weeks before the start of the session. You want something like that, okay?
Yeah, somewhat.
Okay. Actually, the
Anyway,
thing is, it's time taking for me to watch the videos. That's why I ask you doubts, and the doubts, as per the doubts, I prepare the
because you
solutions.
people's already you all know, right? So,
I know, but I need to see the video what sir was teaching at that particular moment,
oh,
because my
okay.
knowledge is now intuition
Oh,
based. I have studied so many books of networks and social network analysis that
yeah, yeah.
what sir is teaching, what I've studied, these two things might not be per week aligned. Okay,
Yeah.
so I have to study from book. Okay, anyways, I'll try to follow this structure
Yeah.
from next week onwards. I'll teach big plan. Before that, I will just say whatever the things were getting covered. Okay.
Yes.
Week 7 is live now. What was week 7? Let me check. Week 7.
Week 7 still not posted. Week 6 is there.
No, no, week 7 is okay. Week 7 is not posted. Okay. Actually, I got this. I sent the assignment today only, so it will be posted by tonight. The assignment is
So
not here.
that random index, detecting community.
Sorry.
So evolution of community detection method, rand index.
Okay, okay,
So,
okay.
and
Temporal
lecture 10.
changes.
So if these things explained in a live, no, we're getting interested to execute.
Sure, sure, sure. I will do. Just send me a list of topics, whatever you want to be taught. Okay.
Sir,
Uh,
can you give any other example of any real world graph where WCC and SCC are helpful?
okay. Cheating chain.
Okay.
You are in class. One student cheated from other. The third one, fourth one. So the teacher knows you guys have cheated from each other, but the teacher does not care about the path. The teacher will fail each and every one. But you guys made the plan, na? So this person will cheat from this person. This person will cheat from this person. So ultimately, okay, this person might share the answer back to this person. So you guys planned everything. Okay, and for you that sitting arrangement, for you that everything plan execution mattered, because if the person one person was made to sit some other place, your whole graph will be broken, and you will be a giant component, that person will be another component, but your chain is broken and now you cannot complete your home cheating thing. Okay, node 4 is
Yeah,
gone,
got
node
it.
4 is gone. But if I reverse the arrow, but somehow the teacher comes to know like some part of like node 4 wrote something and you wrote something, so now you people might start cheating individually,
Mm-hmm.
and you will be getting caught but node 4 will not be getting caught. But you might in later on reveal that yeah, node 4 was also involved in cheating although you removed them. but it was also involved. So like that, it's not a very uh, proper example, but that's how they are used. You want to check
Right.
if the nodes are connected somehow. So that's why you do WCC, because you cannot perform SCC on strongly on a directed graph. You want to check if this person has been emailing this person, or if this person is involved in this conversation. So that's when WCC comes into use. Hello?
Yeah.
Yes.
Yeah. So what I was saying is that WCC is only used to just check whether the node is involved in communication, or in is a part of that network, or is a part of that directed graph. The term directed graph is important here, because mathematics was written. These two terms are mathematical terms. They are used to differentiate. If I cannot say I have a connected network of a directed graph, I have to say WCC or SCC. That connected network or connected component does not mean anything in directed graph. I have to be specific what I'm considering. If I'm considering edges, directions, or not. Okay.
Yeah. Got it.
Okay. Chalo.
Sir, is it possible to get a data set like this if I want to collect the data set of my university?
You
Okay, so all the
have,
students enrolled, and I want to evaluate like that. Is it possible?
frankly speaking, it's very difficult.
Okay.
Okay. I'm not demotivating you.
So actually, in a research, actually what we are doing already having it some data set, we have to take the data set and we have to apply some algorithm. And they are telling that we have to what new thing we have to implement in that particular algorithm so that the result will be different, right? So that's our research process.
Okay.
That's it. I'm asking.
Can you repeat again?
So actually, in a research,
Mm-hmm.
we are taking some data set.
Uh-huh.
Right? So we are applying some algorithm.
Uh-huh.
So based on that algorithm, how its accuracy or something, how the prediction and accuracy and correlations and all we are identifying,
Mm-hmm.
right? And we are applying something, some new things to that algorithm or model.
Okay.
So based on that, how the accuracy and predictions are varying,
So you want
right?
to modify the data over
That
time,
is
or you want to
research.
modify?
So that is research, right?
You asking what is? Just let me speak, okay? You are asking what is the research methodology in network science?
Not just I'm asking
Okay,
PhD
okay,
research work. That
okay.
means
So
is is that everyone is doing?
no, 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 no. Like some people are doing it differently. Okay, so this question is very abstract, and the answer which I'm going to give will also be very, say, not clear. It will be a blur answer, because it's a very descriptive thing to talk about research, how research evolves for a person over time, or how a PhD evolves over a time. Okay, so when you start, you have just one problem statement in mind. Okay, you want to explore social networks. You started your PhD with that. Okay,
Yes.
but then over time you saw some loopholes, some gaps in research, like these people are expanding network, but they are not keeping this thing in mind. So you start working on that thing and keeping that thing in mind, and you propose some new problem statement, and you say, yeah, network expansion problem did not consider the fourth law, the expect from power law, local clustering coefficient, scaling, etc., etc. There is also a fourth law which these people did not consider, and you propose that law, and you show this law exists in social networks in real world data, and then you propose how to inculcate that law in social network. So that is one thing. Then you can improve over the previous results by, say, Barabasi, that guy used temporal thing to increase the degree thing, but what you can do is you can use average degree to improve, or you can use some other thing to improve. So that is subjective, very subjective, and that depends on person to person. A lot of people are working in social network analysis along with me, and their research might be in completely different direction compared to mine. Okay.
So, like, I know, like, we are out of time, but can I ask one last
Mm-hmm.
question, if it's okay?
Okay, okay, ask.
Yeah, sir. Like I have a doubt. We are learning all these properties of graphs, right? Like how to analyze a graph based on these properties.
Hmm.
But I have seen a lot of people directly use deep learning or machine learning to learn the properties of a graph. So my question is, when do you think we should use deep learning and when?
In research, you cannot just use deep learning and expect the reviewer or people to understand why did you use it. To explain the why
Right.
part, na, you have to perform this stuff.
Okay.
Okay, so to show why did you use this algorithm, these many layers, okay, why did you say you want to use node degree, you want to learn node degree in that network, so you show ki this performing like this, you use a network, and you showed that this is performing like this because of the network degree. Okay,
Okay.
so that is, but the reviewer will say, yeah, but network is learning degree how, so then you show some proof, then you use that formula, okay, then you show. So that is again subjective, like you have to perform some exploratory data analysis, and that can only be done using classical methods, and then you apply machine learning algorithm, what suitable algorithm you want to apply, that is ultimately done as per after studying that data analysis part.
Okay. So like understanding which model to use, how many layers to
Yes,
use,
yes,
we
that,
have to do.
yes, we have to do this stuff before, so that we come to know what we are going to use. Okay,
Understood. Yeah. Yeah.
cool then. That's all I guess then.
Yes, sir. Yeah.
Chalo then, see you next week. Okay, bye.
Yeah. Thank you, sir.